Okay, so thanks for sticking around. I think this is the last talk of the day. To infinity and beyond the small team. That will be my first and last reference to being in California, so I do apologise. As a Brit, that's pretty close to Hollywood, so I thought I could get away with it. I work for Cisco, but that's not switches and routers. I work on Videoscape Unity family of products. So that is software for the TV. So that's the head end, or it's akin to the back office. And it's everything that needs to be available for people to actually be able to watch TV. So that's the metadata that goes into the EPG for the next now information, audience measurement, billing, targeted advertising, recommendations, content management systems, push VOD, pull VOD, conditional access. I'm the author of the M2 release plugin as well, so if anyone is using that and wants to bug me about it, then catch me afterwards. And the purpose of this talk is I'm going to cover a little bit about some hardware, a bit more of template goodness. So this is a CloudBees enterprise plugin and how we use it, and how to make the most out of your hardware. So we've got a couple of assumptions and philosophy that goes into our builds. The main one being that reproducible builds are king, and by reproducible I mean repeatable and traceable. Not a lot of here actually impacts to what I'm going to say, apart from really the CI is vital as it's used to make our releases. So if the CI is unavailable, we can't release our software. We can't release our software. Developers get a bit angry, or more to the point, the project managers get angry, who then bug the developers, who then get angry, who then bug me. We didn't until recently have a full-time build guy. I'm getting closer and closer to that. I'm not quite a full-time build guy yet, but I am the one that looks after our CI. I look after our Maven infrastructure. We are predominantly a Maven shop, so it's mostly Java with some Flex, bit of C++ here and there. Like I said, or like Rob said before, we trust our users not to be malicious. I don't trust them not to do daft things or to read any documentation or to have well-behaved unit tests, but we trust them not to deliberately go out and try and break things. We have multiple branches of the same product under development at once for support and feature, and it's multi-region as well. So everything I'm going to say is applicable to our environment and it's lessons learned from our environment. I would say our environment isn't anything special, but everyone's environment will differ. So I'd like to take this opportunity to once again quote Kosuke, completely out of context, when he says, just use more hardware, it's cheap. Now, I currently now work for Cisco as opposed to NDS, and Cisco do actually make some really great x86 servers, but the hardware isn't free, even internally. It may be cheaper than it was, but we still need to use it widely, and it does have a cost, and it's not an insignificant cost. So despite working for the hardware company, we do need to get the most out of what we've got. So a little bit of history. 2007 could have been earlier. It's the earliest recorded thing I've got. It could really be 2006, but I'm not quite sure. We started using Hudson. It was me and another guy, so that was the small team. It was a small team of 2. I kept checking in changes. He'd check in at the same time, and he'd break my changes, and I'd break his changes. So in terms of the project, this is really pretty much as small as you can get. You could halve it, but then really would you want continuous integration? You may do. So in 2008, we had a few more projects and then another instance for another team because the team came along and went, hey, that's great. And what I should point out here is we had no budget for this, so this was running on whatever old hardware we had lying around the lab. It was stuff that was no longer useful for running any QA tests, so it was kind of already 3 or 4-year-old hardware. So because of this, then we started having a plethora of instances, upgrades, testing, maintenance, and there was different configuration versions of masters and the configuration of the jobs. But in 2009, the division realized that actually we want to go down the continuous integration route. Let's use Hudson, because it's brilliant. And so we had a consolidation, and we had a standardized build, which was Maven, and a standardized CI process. And the standard process was not always adhered to. It was a template job that was set up, and a developer would then go, I want a new job, so I'll copy this. Obviously, over time, the template jobs get updated, but nobody goes and deletes their job and recreates it from scratch. So in 2010, we actually integrated Hudson with VMware. Well, actually, Costco did it for us. And then later on in early 2011, we started seeing some performance issues from the hardware that we'd chosen. 2011, we moved on to job templates, which is a CloudBees enterprise plugin. So we've got approximately 800 build jobs on one master. If you add in folders and all other jobs that aren't necessarily build jobs, it's probably pushing to about 1,000 jobs. We have a similar setup in multiple regions as well. So we have almost a rubber stamp copy. Wherever we have source code, we have a rubber stamp copy of the CI environment. So along the way, we started with Hudson. We then used the InfraDNA products. We then moved over to Jenkins. We then moved over to CloudBees Nectar. We then moved to CloudBees Enterprise plugins as things get renamed. And in 2012, the templates went live for jobs. And I'll discuss a bit more about templates in a minute. But we're in 2013, and in January, as I returned from Christmas, and I thought, well, the CI system will have had a nice break. Everyone's on holiday. No one will be doing anything. Jenkins was in meltdown. So it would run for about 3 hours before grinding to a massive halt. So we had a load of performance issues, and I'll discuss a bit about those. We started scaling up our automated acceptance testing, and I'll go on to explain about that as well. And we started actually with the acceptance testing and getting the performance out of it. We realized that we needed to manage the chaining of these, so that was the introduction of the Buildflow plugin. So the original hardware, which was Take One, was a Solaris NFS server running on x86 hardware. It was underutilized from storing large transport streams. So we're talking multi-gigabyte files that were used for QA testing, and it had 6 terabytes of storage, of which we were using probably about 1. So hey, we've got a load of storage, we can use that. We had some servers that we bought, and initially it worked really well. But after 2 years, we added more and more jobs, and then it started to strain. It ended up with jobs taking 30% longer to run on the CI system than on a developer box, and the master was slow to respond. And this was actually sharing resources with other general purpose virtual machines. So the other virtual machines started to become slower. So we actually looked into that, and actually the storage, or the NFS, was the limitation. And we actually investigated many solutions here and rejected almost just as many. We looked at, was it the Solaris NFS server? So we looked at using the corporate NetApp filer, which is supposedly NFS bread and butter, but that was just as slow. We looked at other disk-based SANs, but they needed too many nodes or cost too much. We looked at SSDs. The enterprise with lots of constant I/O was actually very expensive. Remember, this is back in 2011, or at the start of 2011. And there wasn't a lot of space available on them. So that was the investigation that showed that. But actually what we came to realize is Jenkins has a need for different types of storage, and they actually conflict. So you want cheap storage for your build artifacts. You want to be able to keep them. It needs to be large. You don't care if they disappear. It's not the end of the world. So it just has to be large and cheap, good enough. You want fast for your build workspaces. You want your builds to be as zippy as possible. Your job configuration, when you load up, you want to be able to get your job configurations and edit your jobs as quick as possible. and your build reports. So you want to be able to do the trend reporting. You don't want to have to slow down to read all your build reports. And you also need some form of redundancy. So you need your job configuration backed up somewhere. Your build reports, you want to keep those around for a bit. So we had take two. So we actually split things up. So we had the NetApp as a redundant data store, but we don't actually store any master or slave workspaces on here. What we have is the CloudBees backup plugin that is actually mounting that. So nightly, it backs up all of our configuration onto this, onto the NetApp. We bought some new servers. So at the time, they were stonking fast. So it's two Intel x5690 CPUs, 144 gig of RAM, and because we wanted oodles of I/O, we had 16 200 gig SAS drives connected to one RAID controller with 1 gig flashback write cache. And we also had a separate server for acceptance tests, which was slightly less spec'd. So we didn't actually want to run the virtual machines from a local disk for this, so we actually stored those on the NetApp. So that was 2011, but it was 2013, and we're seeing issues again. So the builds are still fast, but the master can be slower, especially archiving the builds, loading old check style results, going into the test results. So for example, one job, 17 minutes for Maven to finish, 2 minutes for Jenkins to archive. When loaded, we're going to 20 minutes for Maven to finish and 23 minutes for Jenkins to archive. So we looked at a few things here. Looked at moving builds to a RAM disk, what to do with failed builds, keeping the workspace around. But that didn't really help us because it wasn't the slaves that were the issue, it's the master. And it's all to do with the I/O on the master. So again, we looked at SSDs, but with our master pushing 40 megabit per second random writes for 12 hours a day, we did some calculations and we'd wear out an I/O drive in about 3 years. And obviously, if we've got faster disk access, we'll be doing more builds. We'll wear it out faster, and we'll also be adding more and more jobs, and so that'll come down and down. So we investigated the PCIe SSD, we investigated flash array storages, but at the end of the day, we went, actually, you know, we need to make sure this works. So take 3A, which was oh my God, I need to get us out of this big hole where Jenkins is falling over, was to go out and buy a commodity off-the-shelf SSD and stick it in our enterprise class server. Shoehorned it in, and I was hoping to see some improvements. And this is before lazy loading landed. Our old startup time, 16 SAS disks, was 3 hours in cold and 2 hours warm. And so warm is, we're just restarting Jenkins, and it's 2 hours to come up. With the SSD, who wants to see if they can win a prize for thinking how long it'll take to start up from cold? Anyone? 20 minutes? Any advance on 20 minutes? 3 minutes. It is an outstanding difference. I wasn't expecting anything near that, and this is before lazy loading landed. To do a warm start, we're down to 2 minutes, and that is just a phenomenal difference. So really it is, I/O is king. Now in May, lazy loading landed, and the startup time went from 3 minutes. Kosuke, what do you reckon? It went to 3 minutes. You did all of that work for nothing. And the cold startup time went from 2 minutes to 2 minutes, which really, really threw me. But hey, you know, we're still down at 3 minutes, so I was a happy chappy regardless. But I wasn't really a happy chappy because we moved to this to pick up a bug fix that we needed that was in 480 that had been fixed. And some page load times became absolutely awful. So the thing to remember here is not everyone's use case is the same. So lazy loading was the big fix that would solve everyone's problems, and it made ours worse. So what we did to work around that, increased maximum heap size. So I think we doubled it from 12 gig to 24 gig to try and stop garbage collection kicking in as often. We've had several lazy loading issues reported and fixed by CloudBees. And I'm probably going to say that 1.509.4 is probably the first LTS with lazy loading with at least the majority of all of these issues ironed out. Even with SSDs, we still see a big load on it. So it's not unusual for us to be pushing over 7,000 IOPS second, which is equivalent to about 35 SAS disks, and that's just for the master. So that's discounting any slaves. Even then, we're still seeing abnormal performance times sometimes back from the disk. So it can be 1 second sometimes to service a read request. But that's certainly better than the 15 to 30 seconds we were seeing with the old disks when they were under load. Now, this could be the array controller or the driver, and I'd like to point out at this point that it's not Cisco hardware that it's running on. It could be the SSD doing garbage collection because of the lack of trim support in VMware. However, regardless, it's not really an enterprise solution. And in fact, we ran this in production for about 2 weeks, proved it worked before I went, actually, this is a commercial grade disk. Do I really want to trust everything onto one disk? Despite the fact we've got backups, I really didn't want to have to come in at the weekend and recover everything. So we actually upgraded to 2 SSDs in a mirror. We now have 3, so we've got 2 in the mirror and 1 standby in case it fails. But it's not an enterprise solution. So we're further along. This should have been already in place, and I should have been able to give you a lot more information about this, but unfortunately I can't. But what we are looking at now is a proper all-array flash array backend for the master. So I said putting the critical infrastructure on a pair of consumer-grade SSDs didn't fill me with confidence. So we looked at PCIe SSD, but we're expected now that we're becoming, or that we were acquired by Cisco, to actually change what we were delivering from delivering RPMs to maybe delivering virtual images. So we looked at that and thought, well, actually, is the size really going to work for this? And we thought, actually, it's not. Local SSDs, enterprise SSDs are just too small, and they're too expensive. And then, they're only for the master. We are getting new hardware. We do need to desperately add more slaves, and that's especially for the machines hosting acceptance test virtual machines. So we're looking to get Cisco UCS blades, and they're limited actually to 2 local disks. So, you know, what are we going to do with our build workspaces? We've got the option of RAM disk, TempFS or RAMFS. We may need a custom workspace archiver so that a developer can still browse the workspace for failed builds, or we could use the flash array. But at the moment, we don't really know how this would impact the master because we haven't got this flash array in place. So we still need to do a lot of testing around that. Now, earlier on, I mentioned there was a need for different types of storage, and there's a feature that has gone into the latest Jenkins. Don't think it's in the new or what will be the next LTS for pluggable storage. It is or it isn't? It is. Oh, it is in there, so I might be able to do something soon. So the pluggable storage allows you to actually separate out where artifact storage will be kept or where job configuration will be kept. So we can actually have multiple storage types on the server, and Jenkins can automatically say, actually, this is a build artifact, slow, cheap storage, or good enough storage. This is configuration, trend reporting, things like that, uber fast. So that will allow us to get the best out of the hardware for the least price. So save the fast stuff for stuff that really needs fast. And that's probably about the end of what I'm going to say on hardware. What I'm going to move on to now, I've kind of mentioned it in passing, is automated acceptance tests. So what's an automated acceptance test? It's a test of a running component. It's not a unit test, but a black box test of a running application or set of applications. I'm not going to say how to write them or really how to run them. We actually use Cucumber Has anyone here used Cucumber? One person. Two, cool. Generally, the tests are long running. And because we want to actually test the component, we want to actually test it in a known state. So we have a pool of clean virtual machines in a known state, and that comes from an enterprise plugin from CloudBees. When a job starts, Jenkins allocates one or more virtual machines to the job, and it takes those out from the pool. So the virtual machine is generic. We don't have to create specific virtual machines for the jobs. Most of our software will run on some form of Red Hat or Linux software. We've got a certain amount of base packages we needed that are pre-installed, but everything else then is a known state, so all we have to do is install our software on top and configure it and then run. We don't have to worry then about, did the previous build actually trash the environment? So that's great, but say you got through code review, you got through and you did an automated test and you installed the RPM package, but actually it ended up deleting etc hosts or some vital piece of information. You're then going to constantly fail until someone goes and fixes that acceptance test environment. But with the clean VM in a clean snapshot, we always have a known good state. So the environment variables get injected into the build to give you an IP address of a virtual machine. And if we want some specific state, so we want to actually test, can we upgrade data? So say we've got some database and we want to test that we can upgrade it from a version that a customer's got to a later version. We will actually have a dump of the database and the acceptance test job will load that in. So it's still running on the clean virtual machine, but then it's recreating the state that it wants to. This makes builds repeatable, but also it reduces the amount of different pools of VMs we need. Plus it also allows the developer to actually go and create the environment that they want to test in. They don't have to come back to me as the not full-time build guy and say, hey, can you go and put this on the virtual machine because I need it for testing. So before I show you this demo, this is all running off my laptop because I wasn't sure what the connectivity was going to be like here. Now, the VMware plugin from CloudBees, it needs ESXi. You can run it against a standalone ESXi, or you can run it against a vCenter. So this is running against an ESXi machine, which is actually running itself inside of virtualization because I can't run ESXi directly on a laptop because I need Windows for this. So there's virtualization inside of virtualization. So if it's slow, that's the reason why. So if I move that over onto the screen, I can no longer see it over there, probably. There we go. If I do it this way, it's probably easier. Yeah. So here we go. We can see the pool virtual machines. So pool virtual machines. I've already set up this for the demo. So I've got a machine center called Demo running on my ESX host. I've entered my root password. And then I've got a static machine pool. You can actually have a static machine pool or a folder machine pool. So a static machine pool is you statically define the names of the virtual machines that you want. So here I've got a pool name of test VMs. What I want to do when Jenkins will actually check out one. In this case, I want to revert it to the last snapshot and power up. And obviously wait until VMware Tools is available to report the IP address. And I've got two machines here, Jenkins VM01 and Jenkins VM02. And if I look into my ESX, there you go, you can see VM01 and VM02. That's all you need to do to actually define virtual machines. I'm not going to go over the folder pool, but basically, if you had vCenter, you can organize your virtual machines in folders, and you can just point Jenkins at the folder, and then as you add in extra virtual machines into that folder, you just go back into Jenkins and go refresh, and it'll go and pull in all of the virtual machines from there. So if I come in and do an example, so this is a very, 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 very noddy automated acceptance test to show you how this is working. This is just a bog standard freestyle build. And so what I want to do is reserve a virtual machine for this build. And in fact, I actually want to resolve, I want 2. So for the sake of argument, I want 2 virtual machines. I'm going to clean the build before, which should be under delete workspace. There we go. And add a build step. So just to prove that this isn't snake oil, SSH root at, and then just target the virtual machine. We'll just leave it at that for the moment, and when I build that, so we can see here that it's automatically started the 2 virtual machines, and there'll be, if I expand that, reverting to the last snapshot. As I said, this is a laptop. If we kick it somehow. In the meantime, we'll just assume that that's run. We'll assume that it's showing, this ran on something. So I've got an if all else fails job here. So let's just double check that this is the right if all else fails job. It is. So first off, I run ifconfig on the Jenkins executor, then running it on VMIP1, then running it on VMIP2, and then because it's an automated acceptance test, I'm actually fudging some results from Cucumber. And for those of you that use Cucumber, there's a published Cucumber test result report plugin. I'll come back to that in a minute, but in my if all else fails, there we go, we can see that's running on the executor, and here we have running on the slave 1 and running on another slave. So that's basically what you need to know about the VMware plugin. But here you'll see the test result trend. So if you've been using Cucumber, you've generally up until now had 2 options. One is to get it to output in JUnit format, which is less than ideal. You lose a lot of the information. Or to use one of the, there's another Cucumber HTML publisher result, but then you don't get the trends over time. So what we have, we actually have a Cucumber report and a plugin that understands the Cucumber report and converts that into a Jenkins understandable format. So you can actually see all of the features here and all of the tags, and it allows you to drill down. You can see obviously the totals, how long everything took. And if anyone wants to do some math and go, well, hang on, that's not 29 seconds, that's right, it's not 29 seconds, but it is. A test can have multiple tags, so I don't want to double count it. This is the time that it took to run all of those tests. And you can drill in, so within each of the features you've got scenarios, and then you can drill in and actually see, well, yeah, this worked fine. So basically that's just a Cucumber feature file to say run a test. That is in the process of being open source, so should be available to you. It was hopefully going to be available to you before I did this, but our legal department is kind of still dotting the I's and crossing the T's. Oh, that's not working. Yeah. So, you know, that's kind of great. And I've lost my timer now, so I have no idea where I am. So automated acceptance tests, there's generally a commonality in what you want to do. Generally, you don't just want to execute some commands on a machine that hasn't got any software installed. You actually want to get your build artifacts from a particular job. That could be a release of that job or a stable, whatever just built and passed all unit tests. As we're building RPMs, we may as well install them. And then after that, we will want to execute some commands on the remote hosts. So as you see, we could just type SSH, root at whatever host, and then commands, but that is just tedious. We would want to set up config, run tests, start a database instance. We want to retrieve some files from the remote server at the end of the test. So that's test results, application logs. If you don't get the application logs and you have a failure, you've got whatever your failure is, which is generally a message wasn't received. How am I going to fix that? I don't know. So, templates to the rescue. How am I doing for time? 10 more, right. So, the Jenkins template functionality allows you to define templates that you could then reuse. The templates, I introduced them briefly in the previous talk. There'll be more information available on the CloudBees site. Speak to Kosuke, any of the CloudBees people, or me. But there's various types. So here you can see we've got a execute shell on virtual machine. So you can go into it, execute shell on virtual machine. It takes an attribute of a command, which prompts you to. You can add in inline help. Show commands, basically whether you want to echo the commands being run or not. And then set some variables using a Groovy script. And then generate a bash script after that. So here we go, we're just saying we want to execute commands on a virtual machine, root at the VM IP, which has already been done. So if you're having multiple virtual machines, the first virtual machine for backwards compatibility is just called VMIP as opposed to VMIP underscore anything. Build vars we're passing through, so they're available on the virtual machine as well, because otherwise that would be unaware of any variables set by Jenkins. And then we just run the command, and then it's the end of. We can do that with the managed script plugin, but I'll show you something a little bit. So I've got to execute on a specific virtual machine, which is almost the same, but I just did it for the demo. We actually take in the VM, so VM address, which is actually the address of the virtual machine, and instead of setting some variables, we're actually generating a shell script to execute by Groovy, which is doing pretty much the same, just in a slightly different way. Obviously, we're using VM address there. But then the benefit of this over managed scripts or anything else is, say we want to then do start database. So we have an Oracle instance on, we actually have 3 Oracle instances on our virtual machines. So you can prompt for the SID, and obviously we've got 3. One's called cabhe, one's called int, and one's called SSO, and they're options. We want the VM, so which virtual machine is it going to run, start the database on? And this is actually a template transformer. So it will transform this to execute shell on specific VM with the following command, which is su to Oracle and run the command, source in the environment. Don't forget to escape ands, because this is XML. So it's and export Oracle SID, blah, 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 and echo startup to SQL Plus, which is all you need to do to start up an Oracle instance. So if we go back to my if all else fails, I can actually come in here and say, instead of this execute shell, which is actually running, not that one, I'll do this one for argument's sake, sbnif config, I will do execute on, that's the wrong one, execute on specific VM, and I also want to do a start database, so execute on that. I want to do it on VM IP2. And that will also be VMIP. Now, as these are demo virtual machines, there is no Oracle instance installed, just to give you fair warning. So I am expecting this to wholly fail. But then the developer now no longer has to worry about you know, what do I need to do to execute these commands? I don't need to have to worry about doing SSH at this host before every command, or having a shell script that then gets copied over and running. You can still do that if you want. And then that frees you up. So it's very extendable. You can build on previous functionality. So as you see, we chained the start database on top of the execute on remote host. I'm running a bit late, so I'm not going to show you the full extras. You can come back afterwards. So that's no good. So, Buildflow plugin. Executing commands on slaves to perform tests is okay, except eventually you want a more controlled flow. So acceptance tests take a while, and you want your feedback as quick as possible. So you actually really want to break up your acceptance tests into blocks of smaller chunks to get your faster feedback. So instead of just running all your acceptance tests, which may take 2 hours, chain it up. So you've got your smoke tests that take 30 minutes. You've then got the things that run after the smoke test that might take 45, and then the things that run after that might take 1 hour and 15. If something's going to fail, it's more likely to be caught by your smoke tests. So you get a much quicker feedback loop, which means you can then go and fix the issues quicker. There's less context switch on the developer, and I don't need to say finding the issues earlier is cheaper, yada, 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 yada. Everyone, I think, knows that now. So the solution to that is actually the Buildflow, which allows you to create pipelines with the DSL syntax, and it also allows you to register plugins as an extension. This is an open source plugin from CloudBees, and I will say we are using an unreleased version of the Buildflow plugin that I have made changes to. This is a snapshot version that we are running in production. It works, so I'm not worried that it's a snapshot. I'm more worried about the SSD disk failing. So this is just a gentle introduction to those that haven't seen the Buildflow. So the first line there is just, that's how you define an extension. It is a DSL written in Groovy. I'm not a Groovy super expert, but I know enough that I can cobble together something like that. So I've got an extension, my Buildflow extension, so I'm just getting that. Because our AATs want to actually, we're missing a line. The line above is actually calling the extension to actually get the last stable run of a particular project. The runs are parameterized, so we want to actually pass the run that we want to test into the acceptance test job. So we actually build up a set of parameters, and for a run, that is the project full name followed by a hash followed by the actual run number. And we print those out, and then we actually, this is the business end. So we're actually saying build my project AAT master level 1 with my params. If that works, then go and build the level 2s. If that works, then actually in parallel, go and build the level 3 jobs and the custom foobar specific job. So this allows everything to run against the same system under test, as well as the same test code. We're passing explicitly down what we want to test. So without this, you would have to then get the upstream, and then when you run the level 3, if you're getting the last stable of the job that you want to test, that might not be the same last stable as the level tests that ran before it, because a commit job will be happening more quicker than the acceptance test can cope with. At the end of this, you could also have your deploy if you're doing continuous deployment. So rather than trying to flick again. So here we go. Actually, I will, because I can't see what I'm doing. So the flow here is actually parameterized. So for the sake of the demo, I'm taking a parameter P because I want to be able to run this, a few of them to show you what the pitfalls are with this. That is pretty much just what I've shown you already. Now the issue here, if I'm actually going to build it, build now, and obviously every build that triggers this, or the commit builds that trigger it, if we want some parameters as well, it's actually going to build block and block and block. So actually we're not going to start testing and getting quick feedback until the previous run has finished. And if that's taken an hour, we haven't really achieved our goal of getting feedback quicker. So what do? Well, you can actually make this run multiple concurrent jobs, and that's fine. But then you will very, very quickly start overloading your Jenkins instance. You will run your build, say everything works fine. If your sequential jobs take longer than your previous jobs, you will end up just backing up and just exploding. There's no point testing build 24 for the final level tests if you also need to test 23, 22, 21, and 27 and 28. You may as well just go, I only need to test the most recent one and the one that's currently running. So to solve that, PowerPoint, yay. So there's a few solutions we can do to solve that. Locks and latches, throttle concurrent builds, constantly buy more hardware, which would be Costco's preferred approach. The problem with those is they're kind of managed outside of the flow, and you really want something inside of the flow. So let's play spot the difference. It's now about 2 o'clock in the morning for me, or 1:30, so my eyes aren't that good anymore. But the difference, there you go. So not a lot in the top extension, but there's 2 extra things here. The ext block. So what does this do? It's part of the extension. If a flow is running and there is another invocation or a run of that flow, it actually adds a block around entering and running whatever is inside it. So if you're the first one to come along, you will enter that and then you'll be allowed to proceed. Any subsequent job coming up will go, is there something inside this block? If there isn't, it will continue. If there is, it will wait. And why do we wait? Well, we still want to test the most recent build, but we don't want to run it at the same time as a build is already being tested for that same level. So we allow the build that's going to run to completion. Then if what the run that was waiting is actually released by the run that's completed, it will then say, well, actually, am I the most recent invocation of this flow that's waiting for this block? If I'm not, abort the build. There's no point testing it. And so that'll run on and run on. So you'll abort until you get to the most recent thing that's waiting to enter that block. And then that'll be released. So that enables us to always run a flow to completion. And other flows can be in previous stages of the flow, but not the same stage. So you don't overload your Jenkins instance trying to run stuff that's not really necessary, but you still have the manageability of the flow and the visibility of that. I'm running short on time, aren't I? Yeah. So I'm not really going to show you exactly that. You can take my word for it. You can actually, the plugin is yet again something I was hoping to say, this is available and you can go and download it and install it. However, due to the legal bod that is Cisco. Hopefully within a week it should be available and you can go and play with it and test with it. So you can actually see a build graph. So the flow started, it ran a level 1 test, that ran the level 2 test, and then in parallel that kicked off the level 3s. Take my word for it that it works, we're running it in production. So there's some links. They don't work because I haven't been given the grant go ahead to open source stuff, but hopefully within the week, certainly before the end of the year, otherwise I'm going to be very, very disappointed. They will be available for you to use. So the Buildflow, don't forget that requires a snapshot build of the Buildflow to run the extension plugin. The Cucumber plugin, it will be available shortly as well. Jenkins Enterprise, CloudBees. I note that the Cucumber plugin can actually run alongside the existing Cucumber Reports plugin if you want to. So if you like that, you can keep it. You can evaluate the two and go, actually, you know, it's given me the same information, but in a better way. So what I've written will actually expose the full test API as well. So if you want to integrate it with other tools, you can actually query a standard Jenkins REST API, get all your information out, so you don't have to then go and reparse any JSON files or anything else. So, thank you to the sponsors, and if anyone's got any questions. Everyone's suitably relaxed at the end of the day. Excellent.